Okay, so we're going to be working with trig again, right? Sine as well as sine, that's fine because, and then area as well. Up until this point, all the trigs that we've done, you were only allowed to use that in a right angle triangle, right? So sine has the opposite over hypotenuse. So that was right angle. Cos adjacent over hypotenuse. Tan angle, opposite and adjacent. Those three trig ratios you could only use in a right angle triangle. And also for area, right? The only way that you know to calculate the area of a triangle works with terms of the height. Okay. So sine, cosine, and area rule. These are three ways or three rules that we can use in triangles that are not right angles. Okay, so I'm just going to make a little note on the side. So we're going to start with sine rule today. I'm just going to draw a triangle here. You can also just draw one. It doesn't have to be a specific type of triangle, but just draw it so that it's not a right angle triangle. As if you have a right angle triangle, you're still going to work with sine, cos, tan as a normal area for you. Okay, so we're not replacing our normal trig ratios. We're just giving a way of working with triangles that are not right angles. So I'm going to call this triangle A, B, C. You might remember from when we learned Pythag, if we have angle A, then we can call the side opposite that angle, we can call small a or lowercase a. I'm confident that we looked at that this year. We did, yeah, we did treat with that. All right, and then for B, the side opposite angle B is lowercase, and the side opposite angle C will be lowercase c as well. So we're working with that location. Now guys, sine rule we can use to calculate the side or an angle, all right? So I'm just going to write here to calculate the side. So what you're then going to do, if you need to calculate the side, you're going to put a side at the top of your fraction. So let's say side A. I'll show you now on a few examples to reuse it. But that will then be over sine of the opposite angle, so angle A. And that will then be equal to any of the other sides. So let's say, for example, side B over sine of the opposite angle. Or, so I'm going to put another equals here, but you'll see how I'm going to use it. You can also use side C over sine of the opposite angle. So guys, just here next to sine rule, I'm just going to write that sine rule always works with opposite sides of angles. So let's see now when we're actually using it in the question. So opposite sides, let's say side and angle please. See what when we actually use it. So those traces are confused. Guys, in a question, we're not going to work with all three fractions at the same time. Okay, it's going to be two of those three. I've just put all three in there to show that you could use any two of them. Right, but we're never going to work with three fractions equal to each other. Okay, so it will be those two, for example, or those two, or maybe even those two. Right. Now, if you want to calculate an angle, you're going to have the same formula, the same rule, but what you're going to do is you're going to put the sine of the angle at the top of the fraction. So to calculate an angle, and then you're just going to put the angle at the top. So you're going to say sine of angle A over the opposite side. Right? In a fraction, it's always an angle and the opposite side of that angle. That could then be equal to any one of the other two pairs. So sine of B over the opposite side. That's more B. Or that could also be equal to sine of C over the opposite side. Again, we're never going to work with all three fractions at the same time, but any two of those three fractions equal to each other. Now I'm going to just do an example so you can see how this works. Alright, now guys, in this case, you need to just look at what x actually is. Do we see that x is a side? In this case, right? Because you can see that it's written next to that line. So in this case, x is a side. So we're going to use the first version of this rule, where we put the side at the top over side and the opposite angle. Alright, so the side that we want to find is x. So I'm going to write x over. Now guys, we need to ask yourself which angle is opposite x? 66. So we're going to put it over sine of 66 degrees. Right. In a fraction, it's always a side and the opposite angle is in one side. And that is now equal to, now guys, when you are working with sine rules, you need to have one pair of the side and the opposite angle that's given. So I'm looking at this proof here, right? 15 and 55. Right, so we see that we have that. So now I started with the side at the top. So in my second fraction, I also have to write the side at the top. Right? See, what did I say here? Side over angle equals to side over angle. Okay, so the other side that we have, or the one side that we do have, is 15. So we're going to put that over sine of the opposite angle, which is 55. And that is all you need to calculate x, right? If I want to find the value of x, what am I going to have to do with the sine 66? Multiply on the other side. All right? Calculate the calculator, and that's going to give us our answer. Sorry. So guys, this will be your first mark always. It's actually showing the summing into the sine rule. And now to get x on its own, we're going to say x is equal to, and I do want you to write this step down, because you do actually also get a mark for writing this step. So 15 over sine 55 times sine 66 Alright, on this side, I'm dividing by sine 66. On the other side, I have to times by it, multiply. So that's what you're going to type into your calculator, guys. 15 over sine 55. Just make sure that you then close your bracket after the 55. Close. Okay. And then you use your arrow button and then you say times sine 66, close your bracket, and that will give you an answer of 17, sorry, 16,73. Okay, so you're on to do this. So x is 16,73 degrees. What am I doing? Centimeters. Sorry, I was thinking of the next example already. 16,73 centimeters. Okay, and that's basically it, right? That is how you use sine rule to calculate the sine. Okay, I'm going to give you one thing to do on your own before we move on to an example of calculating an angle. So I'm just going to give you another one. So sorry, we're drawing lots of triangles today, but at least it's not a very complicated picture. Alright, so this is again A, B, and C. Fifty-three centimeters and X. And we have 35. And we have 54. Alright, guys, I want you on your own to calculate this. Guys, something that I forgot to mention in the first question, but now if we're looking at this one angle, do we notice that neither of these two triangles are right angle triangles? Right? We don't have a 90-degree angle. We could even calculate angle A in both cases because we have the other two angles. And if we did that, we would see that these are not right angle triangles. So we couldn't just use sine cosine. I was at 23.40. It was 396. So then I just rounded it up to 2 decimals. Right, so you would take x over sine of the opposite angle, which is 35, is equal to, we have our other pair there of an opposite side and an opposite side and angle. So 33 over sine of the opposite angle, which is 54. So then you take that fraction and you just multiply by sine 25. Just in the previous one also, I forgot to put in the other two ticks, so you will get a mark there. So showing that tick, we're taking the sine 66 over, and then a mark for the answer. Right, so these kind of straightforward sine rule questions where you just apply it, and then make x the subject and type it into the calculator, these questions are always worth 3 marks. Even in matric. Right? You know, very proud if you get a question like this, it's just fun. All right, now we need to do an example where we are finding an angle, and unfortunately the angle ones are a bit more complicated than the side questions. So again, I'm just going to draw in a triangle here. We have Sine. You guys are done copying that down. I'm just going to add here that now in this question, x is an angle. Yeah? In the previous two, x was a side. Now we actually need to calculate an angle. So that means that when we are using sine, we're going to put the sine x at the top. Alright, in the previous two questions, put x at the top, x was the side. Put the sine over angle. Now we're going to do angle over side. So we're going to say sine of x, it's always the angle with the triangle force, over the side that is opposite that angle, right? So in this case is 25. And that is going to be equal to, do we have another pair as an opposite side and angle? Yes, we do, right? 36 and 19. So because we started with a side, sorry, with an angle at the top, sine of an angle, we need to do that for the second fraction as well. So we're going to say sine 36 at the top, and that is then over the opposite side, which is an over. Again, just like in the others, you would get your first mark for doing that. Second step is going to be the same. We're now going to move that 25 over to the other side. We're going to move it across. We're going to multiply by it. So here we're going to be left with sine x, and that is then equal to sine 36 over 19 times 25. Now when we type that into the calculator, let's see what we get. Yeah, I'm getting a decimal, so I'm getting, so that's 0.773, and then there's a whole bunch of decimals after that. After that, so I'm just going to do a dot dot dot. Now guys, this is not x, this is not my angle, this is sine of x. Alright? Do we see that this looks like a trig equation? Sine x equal to a number. Right? Is this a positive or a negative number? Positive, right? So where is sine positive in which quadrants? 1 and 2. So we are possibly going to get 2 answers for x in this question. We're going to have a quadrant 1 answer, which is going to be acute, right? Remember, any angle in the first quadrant is acute. And then in the second quadrant, we're going to do 180 minus the reference angle, right? Which is going to give us an obtuse angle. So now guys, this is like solving a trig equation, going further down, all right? So to get our reference angle, what are we going to do? The sine of that number of 0.773. So just keep that value in your calculator. Press shift, sine, and then answer. And then that will give you a reference angle. I'm getting 50,66 degrees. Now, in the trig equation, we have to write quadrant 1, x equals plus 360 n, whatever, right? In this case, we actually don't have to write that like general solution line, because can I have an angle that is like 370 something in a triangle? No, all right? So for our triangle, when we're working just in a triangle, you can just say for quadrant 1, you can still write quadrant 1 if you want to. X is going to be equal to the reference angle, right? Remember, that is what we always use in quadrant 1, it's just the reference angle. So that means that X could be 50,60 degrees, all right? Again, we don't have to write the plus 360 in because this is a triangle, okay? We can't have 360 plus 50 degrees in a triangle as an angle. All right, and in quadrant 2, what do we do to get an angle in the second quadrant? We're going to say 180 minus the reference angle. So 180 minus 50,66. So that is going to be 120.34, 129.34 degrees. Right, so X could possibly also be that. Now guys, the way in which you need to check, because sometimes this answer won't be that. Alright, so there is a way of checking. I want us to make an extra note here. You can just maybe make an arrow from the second answer. This is what we call the ambiguous case. Ambiguous is like a double meaning, right? So basically like a double answer in a sense. The ambiguous case. And you only need to worry about this when you are working with the sine rule. When we do the cosine rule tomorrow, I'll show you why it's not an issue there. So only with the sine rule, when you find an angle, you have to worry about this. So guys, what you're going to do, right? If you're finding an angle with the sine rule, you're going to calculate both, right? You always have two possible answers. Then you have to check the second one. Okay, so I'm going to write here, check the quadrant 2 solution. Now, the way in which you must check this solution, what you're going to do is you're going to add your quadrant 2 solution to the other angle that you have in the triangle, right? The other angle that I have is 36 degrees. So I'm going to say 139.34, 129.34 degrees plus the 36 degree angle. I'm going to work that out. 165.34 degrees. Now guys, what do the three angles in the triangle have to add up to? 180. So what would happen, right, if I add the two angles together? So my quadrant 2 solution and the angle that I have. If I got an answer that was bigger than 180. Right, I'm going to say that again. If I do this addition thing, I have my quadrant 2 solution, and that quadrant 2 solution is always going to be between 90 and 180. Or we find it that because in the second quadrant, that is what you have, right? An angle between 90 and 180. If we add that angle to the angle that we already have in the triangle, and we get an answer that is bigger than 180, can the quadrant 2 angle be an answer? If I'm adding it to one other angle, I'm getting something that's bigger than 180. No, right? Because the three angles in a triangle have to add up to 180. You can't have two angles in a triangle and it's more than 180. Okay, so we are going to look at some more examples. But on the right here, this is smaller than 180. Right? Therefore, the quadrant 2 solution is valid. So then, if it's valid, you just leave it. If you are adding your quadrant 2 angle, and say the other angle was like 70 degrees, right? Then you would get 190 and something. Then you would have to say, underneath this, you would have to write invalid. Don't write it now because this one is valid. right? You would just say invalid. Okay, but I'll find an example like that so that we can. All right, so guys, that is a bit of an extra scratch, right? I just want you to, yeah, very nothing. I just want you to just look at the calculations here. Is there anything in these calculations? Just ignoring this whole check thing. Anything there that we need to go over again? It's applying sine rule, moving a 25 over, then finding your reference angle. The quadrant one solution is always the reference angle, quadrant two is 189. Okay, then you do that check. All right, I'm going to give you guys a few to practice on your own. I'm just going to check quickly what the ambiguous case thing is in this exercise, so I'll tell you. All right, so it's exercise 2. On page 216. Okay, we've done number 1 together, so I want to keep it's fine. So you don't have to redraw the triangles in your funny field, you can just do the calculation, so it won't take too long, I don't think. So those are the ones that you need to do. I can put 2, 3, and 4 on the board, but then unfortunately number 5 is on the next page. Just quickly write that down. Okay, there you go, guys. We did number 1 together. That's the one that I asked you to do on your own. All right, so that's why you're not doing number 1, 2, 3, and 4, and then number 5 is on the next page. So in number 2, you're finding a side. In number 3, you're finding an angle. So you're gonna have to think of that ambiguous case in there. In number 4, you are then finding a side, and then in number 5, when you get to it, you are then finding. So guys, ambiguous case, that whole check thing is just when you're finding an angle. Okay, 5 is straightforward, you just calculate it.